Here we are looking at an example that's actually a sum of squares as opposed to what we're used to seeing, maybe a difference of two squares. So we can solve this by taking square roots, but we could also solve this by factoring. So in this particular example, I will be showing both methods. And as you proceed and do other examples, I'm going to bop back and forth. And more often than not, we usually do just solve by taking square roots. I do like factoring though, because when we solve by taking square roots, many people will forget the plus minus in front and then only get one solution where they should be getting two. So let's get into it. If we had a situation where we were solving and it doesn't indicate to only find real solutions, so I'm just going to go ahead and solve to my full potential, and I cannot find a way to say factor this. I don't have the bx or linear term of this quadratic, so we can proceed with solving by taking square roots, but you do not take square roots until you isolate the x squared. Don't try to take square roots too early. I'm going to subtract 25 from both sides of my equation, and I will be left with x squared is equal to negative 25. Now, this is exactly where I will go ahead and take the square root of both sides of my equation. When we are taking a square root ourselves in an attempt to solve an equation, we want to account for all possible solutions, so we throw a little plus minus out in front. The square root of x squared, we write x plus minus. Now, what's the square root of 25? Well, the square root of 25 is just 5. I hope we all have that memorized. And as for this negative right there, the square root of negative 1 is the imaginary unit I. So that's how I'm going to take care of that. Final answer, plus minus 5i. And there you have it. Now, at the beginning, I mentioned that I would go ahead and show you guys how to solve this one by not only taking square roots, but also by factoring. So what's factoring look like in a situation like this? Well, I'm glad you asked. Let's look. X squared plus 25 equals 0. It's not the difference of two squares, which we would factor using conjugates, determined by the square roots of the first and last term in this difference that we should have. But how can I change a sum into a difference? Well, lucky you, I know a few tricks. So hopefully we also all know that minus negative is the same as plus. So minus negative 25. Now normally, if that were a positive 25, we would use conjugates to factor one of the shortcut methods. In fact, this is factoring method number 4 in my playlist of factoring methods. And x squared minus negative 25. So what is being squared to make x squared? Or what is the square root of x squared? That would be x. What's the square root of negative 25? Well, the same thing we just saw over here. It's 5i and negative 5i, and that is what we'll use. Minus 5i and plus 5i, obviously either one could be plus and minus, doesn't matter. And there you have it. It's factored. We're factoring it using complex conjugates. No, I don't want to call them complex because they're really just imaginary. But imaginary numbers in our conjugates. Complex conjugates is somewhere else. I shouldn't have said that. But there we have it, right? So zero product property, x minus 5i. Make sure your i's really look like i's and your ones really look like ones in this entire unit equals 0, and x plus 5i is equal to 0. Add 5i, x equals 5i. Subtract 5i, x equals negative 5i. And those are your two answers. Either way, whatever approach you choose, whatever one makes you happy. Just to reiterate, show your work, write it out. When we were graphing the more recent unit people are just jumping to answers, but then they're putting the multiplicity, the behavior at that 0 and graphing with the wrong 0. Because the 4 and -4 were both, x-intercepts, and people were not paying attention to which one had a cubic behavior, which one had a quadratic behavior, or a linear behavior at that 0. So put more on your paper, all right? Hope this was helpful. Hope you thought it was easy. Yay. Good luck. Click through to another example or go to the playlist, and I wish you all the best.